Now we're asked to evaluate some composite trig functions. In other words, we're doing first the inverse sine of something and then taking the tangent of the result. So this does have some usefulness as you get into other areas of mathematics. And let's just go through this right now. I find it helpful to remember what a tangent function wants as the input. Okay, tangent functions, or cosine functions, or sine functions for that matter, these trig functions, all these guys right here, all want to act on an angle. Okay, so you know the arcsine, the inverse tangent, the inverse cosine, these things, those are all going to be angles. So let's go through it one step at a time. We'll do what's inside the parentheses first. And you can think about it this way. The tangent of an angle, right? So what angle is the arcsine of -1/2? Well, if you find the y value on this unit circle that corresponds to -1/2, there's one. And you know what? There's a lot of red in this picture already, so I'm going to use something that stands out a little, obnoxious pink. -1/2, right there. And also over here. Now you have to remember we're using a limited range of angles. We want to restrict ourselves, since this is sine that we're talking about. We want to restrict ourselves to quadrants 1 and 4. So that angle is not going to be used. We're only going to use 11 pi over 6. Okay, or if you prefer to think in degrees, we can do that. 330 degrees. Okay. Now the tangent of 330 degrees, you should have that memorized, but it's -1 over radical 3. Or if you want, you can also say, you can rationalize that and say -√3 over 3. Those are the same thing, and you'll get marked right for either of them. Okay, I'm not going to nitpick you over whether you rationalize that fraction. Okay, so that's an example of how this works. Let's do cosine of the inverse tangent of -1 next. Well, where on the unit circle, first of all, let's answer this question. Where on the unit circle is the tangent of something -1? What angle is this going to be? Well, tangents, first of all, tangents are equal to 1 and -1 at these places. Okay, these places on here, those sort of perfect 45-degree angles in each arc. Now, the negative ones are quadrants 2 and 4. And then you have to remember that tangent is limited to quadrants 1 and 4, not quadrant 2. So that means our answer is going to be 315 degrees. Okay, so this is going to be cosine of 315 degrees, which according to the x value for that position is radical 2 over 2. Okay, and that's the way you go through this. You find your angle first, then you plug that into the trig function on the outside of the parentheses.